Okay, in this video we are going to practice properties of definite integrals. Which are the properties of definite integrals? So, integral, well, they are very similar to improper properties of indefinite integrals from a to b, k f of x dx is equal, k comes out, a to b f of x dx. And next one is going to be integral from a to b f of x plus minus, let me put minus this way, f of x plus minus g of x, yes, dx is equal integral from a to b f of x dx plus minus integral from a to b g of x dx. Okay, so we will start working on these properties with first example of evaluation of definite integral. All right, so we have integral 1 to 3 negative x squared plus 4x minus 3 dx. Using each of the following values. So integral from 1 to all the way to 3 x squared dx is equal 26 over 3. Integral x dx from 1 to 3 is equal 4, and integral from 1 to 3 dx is equal 2. Okay, let's solve it. So what do we have? Equal, we are getting integral from 1 to 3, it's going to be negative x squared dx plus integral, let me move this a little bit further, okay, creating space, so from 1 to 3, okay, 4x dx, I'm splitting this polynomial, right? And then 4x dx and then plus integral 1 to 3 negative 3 dx. Okay, so what do we have from here? Using the first property we have, we take constant out. In this case, it's going to be negative 1 to 3 x squared dx plus 4 integral 1 to 3 x dx minus 3, right? Because we have negative 3, 1 to 3 dx. Okay, so, and we have values, right? And we'll see how we're going to solve it. So here we have integral of x squared dx. It's going to be equal negative 26 over 3, right? Here we have 26 over 3 plus 4 times, since we have integral of x dx is 4, so we are multiplying 4 times 4, right? And minus 3 times, this one is going to be 2, right? Here we have. Now, see, as you can see, I didn't plug 1 and 3 because in this part it's already counted everything, and value is already given. Yes? Okay. So, and the answer is, if we calculate, it's gonna get 4 over 3. Next, we have definite integral from 1 to 3 x squared minus 3 dx. Okay, so this is going to be equal. So if we use property of definite integral, we are going to get x cubed over 3, limitation from between 1 and 3, and then minus 3x, limitation is from 1 to 3. Okay, so this is equal, so I'm plugging 3 cubed over 3, I'm using this 3, right, plugging this 3, all right, over 3, minus, next I'm plugging this 1, so it's gonna be 1 to power 3 over 3. Okay, minus. See, I put parentheses because I'm going to add some parentheses there, and I will need to change the sign. Okay, you'll see. So parentheses, we have 3x 3 times 3, right? Okay, since there is no division, let me write down 3 times 3. And then minus 3 times 1. And we are getting, so 27, here we get 27 over 3, it's going to be 9, minus 1/3, minus 9, and plus 3. 9 minus 9 is gone, so we get 3 minus 1/3. 3 minus 1/3 is going to be 2 and 2/3. There is very easy way to subtract. I will place the video reference at the end, to the video at the end of the screen, where you can go and look basic subtraction from the fraction from the whole number. It's very easy. You don't have to go through lakes and mountains to do simple subtraction. So you can go and see, and you will understand how I subtract right away. Okay. Next question, number 3. We have integral, definite integral from 1 to 4, 3 square root x dx, which is going to be equal 3 integral between 1 and 4 x to power 1/2, right, dx, and this is equal 3. So x to 1/2, if we take integral, it's going to be x to 3 over 2 to power 3 over 2 and divided by 3 over 2, right? And this is going to be 4 boundary between 1 and 4. Okay, so you remember, right, how we take integral? It's integral x to power n dx is equal x to power n plus 1 over n plus 1, right? Okay, so from here we are getting 3 times x to power 3 over 2 over 3 stays there and 2 comes here, right? Which will cancel this 3, and that's gonna be limited by 1 and 4. Yes? Okay, and from here we are going to have twice times 4 times 4 to power 3 over 2 and minus twice 1 over power 3 over 2. Okay, so what do we have here? This is going to be equal twice. So 4 to power 3 over 2, it's going to be square root 4 cubed, right? Minus, well, minus 2. 1 to any power is going to be 1. Okay, how much is cubic, the 4 to power 3? It's going to be 2 times square root 64. Yes? Minus 2, and that's going to be equal 2 times 8 minus 2. 16 minus 2, we are getting 14. All right, moving to next question. Question number 4. We have integral between 0 and pi over 4 secant square x dx. All right, if you remember, let me write down, refresh your memory. Integral of secant square x dx is equal tangent x, and that's a table integration by table. Let me see. Okay, which means here we are going to get tangent x, and we are limited by 0 and pi over 4, and that is equal 1 minus 0 equal 1. Because tangent pi over 4, let me go slow. Okay, so we are getting tangent pi over 4 and minus tangent of 0. So this is equal, tangent pi over 4 is 1 and tangent of 0 is 0. So result is 1. Okay, next problem. So we have this such graph. Okay. All right. This is 1, this is 2. So this is going to be 1. All right. And the graph looks like, no. Okay, this is 1, and I'll do this one also. Okay, so This is 1. This is 1, this is 2, so this obviously is going to be 1/2. So what do we need to do? We have in the integral 2x plus minus 1, the graph of which we see on the right side, dx. So using this graph and the definition of absolute value, we want to find the area of this shaded part here, right here. There we go. And this one. Let me shade, allow me to shade real quick. Okay. All right. Here we have this shaded area. Okay, this is good enough. So to find the shaded area, what do we need to do? What is our boundary? So low end is going to be, so to find boundary we identify on x-axis. So which means it's going to be from here, right? 0 and go all the way to these two, right? Shaded area. Therefore, low boundary is going to be 0. Higher boundary is going to be 2. And since we have absolute value, that's why we have it no graph in the negative area of y, and both graphs are in positive area of y. So let me write down. This is equal. Let's evaluate it, see how much is the area. So I'm going to make the area. I cannot figure out the area of both sides at once. So I'm going to figure out the area from 0 to 1/2. Yes, and this is going to be negative 2x minus 1 dx, because which one is negative? This piece, let me see. This is positive 2x minus 1. This is negative 2x minus 1, which we get from this absolute value, and we get what? Negative 2x minus 1 when x is less than 1/2, right? Which is this piece. And positive 2x minus 1 when x is greater or equal 1/2. Yes? Therefore, we are getting this. So from 0 to 1/2, 2x minus 1 dx plus, guess from where it's going to start? You are right, from 1/2. And now it will go till all the way till 2. And it's going to be positive 1, 2x minus 1 dx. So from here, we have, so negative x squared, because what do we have? We are going for this one. We are going to get negative twice x squared over 2, right? This will cancel. And this negative sign in front we have. This is right here, and we'll stay with the other one. So my 1 is negative. Okay, let me write down like that, minus negative x, right? Okay, and this is, will have limitation from 0 to 1/2. Okay, plus it's gonna be same way, twice x squared over 2 and minus x, right? Integral of 1 or dx, it's going to be x, and its limitation is going to be from 1/2 till 2. And from here we are going to have negative 1/2 to power 2, it's going to be 1/4. This one we are working with, right? Next, it's going to be plus. So how much we have? Well, I'm not putting 0 because 0 to power 2 is going to be 0. And then we are going to have I can get rid of this one. Okay, 0 squared, okay, and then minus negative 1/2, right? And then we are going to have minus 0, and then plus, it's going to be x, which is going to be 2 to power 2, right? Minus 1/2 to power 2, and minus, now we plug x. So it's going to be 2 minus 1/2. Yes? First, we plugged practically these 2 to x squared, this one and then this one. Yes? And then we are plugging these 2 to this x. Okay? All right. So let's now solve it, see what we are going to get. We are getting negative 1/4 plus 1/2, and then we are getting what? Plus 4 minus 1/4 minus 2 plus 1/2. Yes? Okay. So what do we have? This negative 1/4 and negative 1/4, it's going to be negative 1/2. This 1/2 and this 1/2, it's going to be 1. And 4 minus 2, it's going to be 2. And we are getting negative 1/2 plus 3. So 3 minus 1/2, we get 2 and 1/2. This is going to be our answer. Solving next one, number 6. So we are given the following parabola. Okay. In parabola, it's gonna look like, let me see. This is 1, this is 2, this is 1, this is 2. We're going to go through 1, come here, and like this. Okay. No, this is 2. All right. So let's see, what do we have? we need to find the area under the region. We need to find the area. Now this one, this time we don't have a cut, right? In the areas like we had last time. So we can calculate it with one integral, yes? In the previous case, we did in summation of two integrals because it was touching x-axis right here, right? So we had to do two integrals and add them. This one is going to be different because the whole this area we can calculate as a one integral. Let me see. All right, we have it. Good enough. So we have y is equal 2x squared minus 3x plus 2. This is the graph we see here. All right, so we need to find the area of the region bounded by graph of 2x squared minus 3x plus 2. Okay, so what do we have? What is going to be our boundary? Our boundary is going to be x1 is equal how much? 0. And then our boundary is going to be x2 is equal 2. So we need to find the integral within 0 and 2, right? So let's write down. If we want to find the area of shaded area, so we are taking integral between 0 and 2. Once again, we use integral to calculate area, volume of the shapes that don't have a right shape. So the shapes when geometry cannot handle. Well, it can be all kinds of like this shape. How can you calculate this area, this shape with using geometrical formulas? We can't. That's where integral steps in. So we have 2x squared minus 3x plus 2 dx, and we are getting, so twice x cubed over 3 limits 0 to minus 3 times x squared over 2 limit 0 to plus 2x and limit 0 and 2. All right, so let's see what we get. Twice 2 to power 3 is going to be 8, right, over 3, minus 3 times 2 to power 2, it's going to be 4, and divided by 2. Why I do skip these zeros? Because it's going to be 0, right, everything, so I don't put these zeros there. And unless if you want me to, okay, I'll put it so maybe for readability would be easier. All right, minus 0, okay, and then next minus, right, 3 times 4 divided by 2, and then it's going to be plus 0 because we need to subtract, and with this minus it's going to be plus, and then plus 2 times 2, this third one we're doing 2 times 2, and minus 2 times 0, right? Or just put 0 because others also I just did put 0. Okay, and the answer is going to be 16 over 3 minus 12 over 2 is 6 and plus 4. So we are getting 16 over 3 is 5 and 1/3. minus 2, and we are getting 3 and 1/3. Okay, and this is the area of this shaded part. All right, that's all for this lecture, for this video, and thank you for watching. So I will record next definite integral as a function. All right, soon it's coming.